Good day to you all. Today we're going to dive into the world of rational inequalities. Rational inequalities are mathematical expressions that involve rational functions, which are functions that can be expressed as a quotient of two polynomials. These inequalities are used to represent real-world situations where a quantity is restricted by a certain conditions. An inequality may have infinitely many solutions. The solutions can be expressed using set notation or interval notation. So this is the interval and set notation table. This is the procedure for solving rational inequalities. Let's have this example. 2x over x plus 1 is greater than or equal to 1. So first, the 1 on the right side must be 0. What we will do is just move 1 to the left side, so it will be 2x over x plus 1. Negative 1 is greater than or equal to 0. Next, get the LCD. The LCD is x plus 1, so times the LCD to 2x over x plus 1, so x plus 1 will be cancelled, 2 will be left. Then multiply x plus 1 to negative 1 or the LCD to negative 1. So negative 1 times x plus 1, that will become negative x minus 1 over x plus 1 greater than or equal to 0. Then simplify or combine the similar terms. So 2x minus x, that is x minus 1 over x plus 1 greater than or equal to 0. Now let's equate the value of this. After this, that's what we call a single fraction. We will get the value of x. So x minus 1 equals 0. Transpose negative 1 to right side. So the value of x is positive 1. The denominator x plus 1 equals 0. Transpose 1 to the right side, so the value of x is negative 1. Let's put the 1 and negative 1 in the number line. Let's figure out if 1 and negative 1 is part of the solution. Substitute 1 and negative 1 to the original inequality. If we substitute 1, let's replace x to 1. 2 times 1, that is 2. Then 1 plus 1, that is 2. 2 divided 2 is greater than or equal to 1. It means that 1 is satisfied. Therefore, positive 1 is part of the solution. Let's shade the positive 1. Second, negative 1. Substitute to the original inequality. If we substitute negative 1 to denominator, it will equal to 0. So it will become undefined. If it's undefined, it means it's not part of the solution. So the circle is not shaded. In the number line, we have 3 intervals, the right side, middle, and the left side. Our interval in the left side, x, is less than negative 1. Our interval in the middle, x, is greater than negative 1, but less than 1, and in the right side, x, is greater than 1. Next, we will make a sign table. How is a sign table made? We'll put the intervals. The test point means we will get 1 in each interval. Let's figure out first the left side. We will choose the closest to negative 1, so it's negative 2. In the middle, we will choose 0, and on the right side, we will choose 2. Let's evaluate the test point that we choose. First, place the denominator that we got, that is x minus 1. Next to x plus 1, then the whole rational expressions, x minus 1 over x plus 1, then substitute each one. Negative 2 substitute to x. Negative 2 minus 1 is negative 3. It is called a sign table because we will only put the signs. Next, negative 2 plus 1, that is also negative 1. In the last part, we will put the multiplied. Negative times negative is equal to positive. Next is the test point 0. 0 minus 1 equals negative, and then 0 plus 1 equals positive 1. Multiply negative and positive, so it is negative. Lastly, the positive 2. 2 minus 1 is positive. 1, 2, plus 1, that is positive 3 because it is the same positive sign, so it is still positive. Since greater than or equal to 0 means positive number, we will only get positive. x is less than -1 is part of the solution, and x greater than 1 is also part of the solution because they are both positive. Your x is all real number, but x is less than -1. Copy x less than -1 or your x is greater than or equal to 1. Why is there an equal? Because 1 is part of the solution. Using interval notation, because we have intervals in the middle that is not part of the solution. How will we present it? From negative infinity to -1, we will use open and close parentheses, since -1 is not part of the solution, so that's why it is parentheses. Union of bracket 1 to positive infinity. Why is it bracket? Because 1 is part of the solution. Thank you for watching this video. I hope you have learned something that I hope this helps clarify how to represent rational functions and solve rational inequalities. Let me know if you have any further questions or concerns.